Welcome students. This video lecture is a part of Boston Public School digital learning program. So this is a chapter 3rd of class 11th, that is periodic classification of elements. Today we discuss about the periodicity. In our last class we discussed about the development of periodic table and different kind of atomic radii, ionic radii. Today we discuss the periodicity. Okay. So what is the basic definition for the periodicity? The repetition of similar properties after regular interval is called periodicity. Where this regular interval we observe the regular intervals in a periodic table, position of elements in the periodic tables. Okay, so if you see the periodic table and the respective position of elements, we, we see the repetition of some of the chemical or physical properties that is called periodicity. What are the properties? These may be atomic sizes, ionization enthalpy, melting point, boiling point. So these properties repeat after the interval of a fixed interval. So this is all are about the periodicity. Okay, what is the basic cause behind this periodicity? What the factor is responsible for the periodicity? So after observation, we find that the electronic configuration of element is the basic cause of this periodicity. Some elements are of bigger sizes, some elements, if we move from left to right in a period, in a periodic table, then we observe there is a decrease in a atomic radii. Okay, we see the regular pattern of decrease in the atomic radius, atomic sizes. So what is the basic cause for this? This is your electronic configuration. The property of elements are the periodic repetition of similar electronic configuration of element as the atomic number increases. Okay, so the periodic cause is their electronic configuration and their electronic numbers. So now let's talk about the different kind of periodic trends that we study from left to right inside a period and top to bottom inside a group. So first periodic trend is nuclear charge, that represented by capital Z. So what about the nuclear charge? It is a total positive charge that present in nucleus, and this positive charge is mainly due to subatomic particle. These are protons, because as you know there are three types of subatomic particles: electrons, proton and neutrons, and there is only proton which carry positive charge. So this is all are about positive charge. And why we consider this positive charge here? Because positive charge is the only charge which attracts the negative charge that present on electrons, and that electron which revolve around the nucleus. If there is no opposite charge on electron and nucleus respectively, then they are not bind with the help of electrostatic force of attraction, and at that time atom is not stable. So to maintain the stability of atom, to maintain electrons continuously moving around the nucleus, we require this nuclear charge. Nuclear charge is basically an attractive force which exerted by nucleus to the electrons which present in outermost shell of an element or atom. So there is another term, that is effective nuclear charge. So what is the basic difference between Z effective and Z? Okay, so nucleus exerts an attractive force on electrons that revolve around the nucleus, but actually that electron feel less attractive force that exerted from nucleus. That electron never feel 100% attractive force. There is a decrement in this attractive force, and this decrement is because of shielding of that attractive force. That shielding is denoted by sigma here, and if we see the formula here, then Z effective is nothing is equal to Z minus sigma. This sigma represent the shielding factor. The sigma represent the decrement in a total attractive force. Okay, the actual attractive force exerted by nucleus after shielding effect. So after shielding, the remnant nuclear charge is called Z effect. So it will never possible that Z effective is greater than Z. Never possible. It always less than capital Z. Okay. Next, effective nuclear charge affect the atomic area. So we must consider it. It is a attractive. Effective nuclear charge is a kind of attractive force which is exerted on a electrons that present on an outermost shell that revolve in an outermost shell. If attraction is increases, then electron that bind with the electrostatic force of attraction will also increases, and because of greater attraction, that electron comes nearer to the nucleus, and because of that, the size of shell get constrict, and due to which atomic radius get decreases. So as we increase the effective nuclear charge, atomic radii will decreases. Okay. So nuclear charge is inversely proportional to atomic size. As the nuclear charge increases, atomic size get decreases. As effective nuclear charge increases, attraction from nucleus increases, lead to constriction of atom. Atom will become smaller and smaller inside as we increase the nuclear charge. And nuclear charge is directly proportional to atomic number, because atomic number is directly proportional to number of protons, and number of protons is directly proportional to positive charge. Next periodic trend is ionization enthalpy, that is represented by enthalpy as always has a sign capital H, and I is for ionization. The definition of ionization enthalpy is the amount of energy that is required to remove an electron from outermost shell of an isolated gaseous atom. Okay. So ionization enthalpy is the energy required. That means ionization enthalpy is always endothermic, because we have to supply the energy. Only that time electron are removed from the outermost shell. So ionization enthalpy is always a endothermic in nature. Thermodynamically, del H is always a positive sign. What is the basic definition? The energy required to remove an electron from outermost shell of an isolated gaseous atom, that is called ionization enthalpy, that always measure in kilojoule per mole. Okay. Now the order of successive ionization enthalpies. Suppose di-positive atoms like magnesium is there. In case of magnesium element, we have two electron in its outermost shell. Suppose first we remove, suppose the electron can be removed one after one. Suppose we remove the first electron from the outermost shell of a magnesium atom, then we have to supply del IH first. And if we have to remove the another electron from outermost shell of an magnesium cation, then we have to supply del IH2. That means second ionization enthalpy we have to supply. So there are three valence electron is present in aluminum. Then we have to supply del H third also. Okay. So what would be the successive order of these ionization enthalpy? You can see here, as the number of valence electron increases, ionization enthalpy will also increases. So first, so there is a minimum energy which is required to remove first electron that present in outermost shell. Then we have to supply more energy to remove another second electrons from that atom. If we have to remove third electron, then we have to supply third ionization enthalpy. And then if we have to remove the fourth electron, then we have to apply fourth ionization enthalpy. And as the successive ionization enthalpy increases, then magnitude will also increase. Now the factors which affect the ionization enthalpy. So what are the factors which affect the ionization enthalpy? Think about it. The atom with a greater size having low IP. Why? Because the attractive force that feel by that electron from the nucleus is very poor. Because of that, we can easily remove this electron by supplying minimum ionization enthalpy as compared to the atom which is smaller in size. So we have to supply more and more energy because in a small atom, electrons are tightly bound with the nucleus with the help of greater attractive force, electrostatic force of attraction. So what are the factors? The first one is Z effect. As Z effective increases, ionization enthalpy will also increases. So the Z effective is directly proportional to ionization enthalpy. Okay, you can understand this factor in such a way that Z effective is directly proportional to number of protons, is directly proportional to number of positive charge. Okay, amount of positive charge, and this amount of positive charge is directly proportional to electrostatic force of attraction. As the electrostatic force of attraction, the electron which bind with the greater electrostatic force of attraction require more and more energy to remove from its outermost shell. Okay. Next one is atomic size. As we talk about already, that the atom with the greater atomic size required low ionization enthalpy. So atomic size is inversely proportional to ionization enthalpy. As the atomic size increases, we require less and less ionization enthalpy to remove an electron from its outermost shell. The next, fully filled and half filled configuration. Suppose an element have a fully filled and half filled configuration in its valence shell, then then we require this both type of electronic configuration are considered to be quite stable configurations, and at that time we have to supply more and more ionization enthalpy. Okay, next one is penetration effect. So what we know about this penetration effect, the shell which present towards the nucleus, nearer to the nucleus, having great penetration effect because the electron present in that shell is greatly attracted by nucleus or effective nuclear charge. Suppose we compare 3s, 3p and 3d, then which orbital is more nearer, just nearer to the nucleus? So the 3s is the orbital which quite near to the nucleus, and because of their nearicity, that electron that present in 3s require more and more ionization enthalpy. Okay, that electron that present in 3s orbital is hard to remove. Okay, so the penetration effect is increases from F to D, D to D to P and P to S. S S in any shell, S orbital in any shell, S subshell in any shell represent maximum penetration effect. Okay, so the electron present in 3s subshell require more and more energy. 3s orbital require more energy than the electron that present in 3p orbital. So now we see the periodic trend Z effective and delta H, how they affect or vary along period and groups. So we find a common graph here. So this arrow represent that we move from left to right inside the period, and that arrow is represent that we move from top to bottom inside a group. Okay, you can compare as we move from left to right, Z effective will increase. Z effective is increasing. Why? Because if we move from left to right inside a period, atomic number will increase here, and atomic numbers are directly proportional to number of protons, and number of protons are directly proportional to nuclear charge. So as we move from left to right, there is an increment in Z effective, and if we move from top to bottom, there is a decrease in Z effective. Decrease in Z effective because as compared to increase in atomic number, there is an increase in comparatively there is an increase in atomic size also. So Z effective is comparatively show little increment or decrement. You can see here atomic size. As we know that Z effective is inversely proportional to atomic size. As the Z effective increases, atomic size will decreases. And if you move from top to bottom, as the Z effective decreases, atomic size will increases. To the next, and because of that, as you know that the ionization enthalpy is directly proportional to Z effective. So as the Z effective increases, ionization enthalpy will also be increasing. As the Z effective decreases, then ionization enthalpy will also decrease. So this is a common periodic trend about effective nuclear charge and ionization enthalpy. So this is all are about today lecture. Tomorrow I will continue with the remaining periodic trends. So I provide you worksheet question and answers. So you have to give answer of each and every question, and you have to learn. You have to note all the questions in your notebook along with the date. And if you got some difficulty, then you can ask in our comment section. Okay, you can see here. First question: how atomic radii vary along group and period? So along group, atomic radii increase on moving from top to bottom. So as you move from top to bottom, atomic sizes will increase. And if we move from left to right inside the period, the atomic size get. Come to the next. Arrange the following in the order of their increasing radii. There are two questions. Sub question A, I minus and I positive. This question is comes from atomic radii section. As we know, the anion is always bigger from their parental atom, and cation having a smaller atomic ionic radii than its parental atom. So the correct order is I plus, then I, and then I minus. And fluorine, chlorine, and bromine, as you know, they all are belongs to group number 17, that is halogen family. And as you move from top to bottom, then atomic size will increase. So the bromine having largest atomic size, the ionic radii, atomic radii among these three. You can see here the answers. So these are the correct answer. Come to the next question number third. Name the factors which affect the ionization enthalpy, as you already mentioned it. Okay, I can repeat again: atomic size, effective nuclear charge, electronic configuration, penetration effect. Now question number four. Explain following. Radius of chlorine atom is less than chlorine ion. That we already talked about it in our previous lecture. Due to decrease in Z effective. As you know, Z effective is inversely proportional to atomic sizes. Okay, so size of chloride ion increases due to decrease in Z effective, and the size of Na plus get decreases due to increase in Z effective. Now question number fifth is interesting. That is your backside question also. Consider the following species, that is nitrogen 3 minus, O2 minus, F negative, Na plus, Mg2 plus, and Al3 plus. What is common in them? So if you count the number of electrons, atomic number of nitrogen is 7, and 3 minus indicate that it gained 3 electrons from somewhere. So total number of electrons become 10. The atomic number of oxygen is 8, and it gained 2 electrons from somewhere. So the 8 plus 2, that is 10, again 10 electrons. F is the fluorine, and 1 minus 1, that means it gained 1 electron from somewhere. So again 10 electrons. So all are having 10 electrons. That means they all are having same type number of electrons. So they are called isoelectronic species. What is the common in them? As we increase the atomic number, Z effectively increases and lead to decrease in atomic sizes. So as we increase the atomic number, so the atomic, if we arrange them according to increasing order of their atomic number, so the aluminum got the first in line. Okay, first position in the line. So aluminum has a maximum number of atomic number. So it also contain maximum number of protons. As it contains maximum number of proton, its effective nuclear charge is maximum, and due to effective nuclear charge, its atomic size is minimum. Its ionic size is minimum because we know that effective nuclear charge is inversely proportional to atomic size or ionic size. So the largest size is of nitrogen 3 minus ion. So this is all about today lecture. Have a nice day.